Hi everybody. Today we're going to review the laws of exponents that you learned in algebra but may have forgotten. So, the first one, any base to the m power times any base to the n power, you add those exponents together. For example, x squared times x to the third equals x to the 2 plus 3 power, so x to the fifth. So why does that work? Remember that the base tells you what you're multiplying, and the exponent tells you how many times you're multiplying by it. So x squared is the same as saying x times x, and x to the third is the same as saying x times x times x. So if we multiply those together, we in fact have 5 x's multiplied by themselves, so x to the fifth. And that's the reason for the rule. When we multiply, we add the exponents is a shortcut for just repeated multiplication. Moving on. What if we have division? Any base to the m power divided by that same base to the n power, we will subtract the exponents. For example, x to the fifth divided by x to the third equals x to the 5 minus 3 power, which is x squared. Why does it work? Well, x to the fifth is x times x times x times x times x. X to the third is x times x times x. Then, anything divided by itself cancels out. Divided by itself cancels out. Divided by itself cancels out. What we have left is x times itself 2 times, or x squared. The quotient rule is just a shortcut for all of this simplification. Moving on. The power rule. If a base has an exponent and it's raised to another exponent, then we multiply the exponents together. For example, x to the 2, x squared raised to the 3 is x to the 2 times 3 power, or x to the 6th. Why does that work? Because an exponent tells you how many times to multiply the base by itself. In this problem, x squared is the base, and the third power is how many times we multiply x squared by itself. So we have x squared times x squared times x squared, and each x squared is an x times an x, and so all of those that put together, that is x to the 6th. Multiplying the exponents is a shortcut for this. Moving on. A reminder that a 0 as an exponent cancels the base out and makes it equal 1, as long as the base is not 0. For example, 5 to the 0 equals 1. X squared times y to the 0. X squared is x squared, but y to the 0 is equal 1. So this is the same as x squared times 1, which is just x squared. Moving on. Okay, moving on. Negative exponents. These are the toughest to get your head around. If you have any base with a negative exponent, what that tells you is actually that your base is in the wrong part of the problem. If an exponent is supposed to tell you how many times to multiply the base by itself, it doesn't make a lot of sense if that exponent is negative. How, example, would you multiply something by itself negative times? Can't do it. So what it's telling you is that this combination is in the wrong spot, and you need to move it in its location. How we move it is into the denominator of a fraction. Think of this a being over 1. It was in the top of the fraction, and so we move it to the bottom in order to move it. So let's try it out with some actual bases. Say we had x to the negative 2. It can't mean x times x because it's a negative 2, not a positive 2. So what that's telling us is that the x to the negative 2 is in the wrong spot. We should flip it to the bottom and it would become 1 over x squared. There, x could mean x times x, and there it would make sense. What do we do with this rule if the negative numbers, the negative exponents, are already on the bottom? Well, this still tells us that our base with the negative power is in the wrong place. And so in this case, we should flip it up to the numerator. So this would be x to the third times w to the fifth. And now that would mean that w would be multiplied by itself 5 times, which makes sense to our brain. So why does this rule happen? It all goes back to that quotient rule and crossing out pairs of x's. So we saw a few slides ago that if we had x to the fifth divided by x to the third, we would subtract the powers and get x squared. But what would happen if that was the other way around? What if we had had x to the third divided by x to the fifth? When we subtract, we would get x to the 3 minus 5, so we'd get x to the negative 2. So this rule for negative exponents is introduced so that we would all know that these x's make more sense in the bottom of the fraction where they started out. And we would say, hey, we canceled off all the top ones, and our x squared, our 2 extra x's, are left in the denominator of the fraction. You can prove that this is true if we try the repeated multiplication demonstration. X to the third is the same as x times x times x. X to the fifth would be 5 x's. And then if we cross out pairs that divide to be 1, sure enough, we have 1 left in the numerator and x squared on the bottom. So basically, the negative exponent rule has created to make up for the quotient rule creating negative exponents. It's reminding us that we should leave numbers where the exponents are positive, and they were positive where the larger number of them were there to begin with. 5 is bigger than 3, so the extra x's should be left on the bottom where the 5 x's were to begin with. Okay, so let's just make up a few examples here and see how we do. What if we had 2x to the third times 6x to the 7th? Think about that for a minute and see if you and I would do the same thing. Okay, first of all, it's a multiplication problem, and 2 and 6 are regular numbers, so they're going to multiply by like usual. 2 times 6 would make 12. Our exponent rule comes into work when we have x to the third times x to the 7th. The base is the same. Remember, these exponents rules work when there's the same base. And when we multiply, we should add exponents. So we should find ourselves doing x to the 3 plus 7 power and get x to the 10th. So if you got 12x to the 10th, you did it right. Okay, let's try another one. What if we had 4x to the 0, y to the third, divided by y. That looks way more complicated. What did I do there? Well, anything to the 0 power is equal to 1. So we have 4 times 1 times y to the third over y. And I should remember that the division rule tells me that I should subtract my exponents. So 4 times 1 makes 4, and I should subtract my exponents. You may be thinking to yourself, but hey lady, that one on the bottom doesn't have an exponent, but it really does. If you can see the y, remember it's y to the first. So that's going to be 3 minus 1, so we'll have 4y squared as the answer to that. Okay, let's try another one. What if we had x cubed y to the fourth all raised to the second? Think about that one for a minute. Okay, this is an example of the power rule. So the power on the outside gets multiplied with the power on the inside. But what about the other power? You're right if you thought that it should multiply to that one as well. The power on the outside of the parentheses will be multiplied with all exponents inside the parentheses. So we'll get x to the 3 times 2 and y to the 4 times 2. So x to the 6th, y to the 8th. Now how about this variation? What if it's 2x to the third raised to the 4th, let's say? Same rule. 4 multiplies with 3. But what about that 2? Does the 2 have an exponent? Yep, if you can see it, it's got an exponent of 1. So 4 should multiply with the exponent 1 as well. So we should get 2 to the 4th times x to the 3 times 4. So 2 to the 4th times x to the 12th. That's a little too messy for words. Let's try that over. There we go. 2 to the 4th is 2 times 2, which is 4, times another 2, which is 8, times another 2, which is 16. Feel free to use a calculator for that evaluating. All right, let's try something else. What if we had w to the negative 5? The negative exponent tells us that these w's are in the wrong spot, so we should move them to the bottom. That would mean 1 over w to the 5th. What if we had y to the 7 over x to the 4th? Negative 4. A negative exponent tells us that the x's are in the wrong spot. The only correct spot to move them to is the numerator. So they would join the y's. X to the 4th times y to the 7th. Notice the y's don't have to move. They have a positive exponent. Just because the x's are moving does not force the y's to move. They don't switch spots. Okay, one more set of examples. What if we had 2x squared over 4x to the 4th? Well, it's a division problem, so we would treat 2/4 like normal. That's a fraction that can be simplified by dividing it by 2, so that would create 1/2. We have the quotient rule, so we should subtract powers. X to the 2 minus 4. Always take the numerator one and subtract the denominator one. So we would have 1, x to the negative 2 over 2. But don't change that channel just yet. We have a negative power, which means the x's are in the wrong part of the fraction. Move them to the bottom, so we could have 1 over 2x squared. Remember, the reason for that is that there were more x's on the bottom of the original problem, and so there's x's still in the denominator in the final answer. Alright, stay tuned for more working class. There's our introduction to our exponent rules.